Hello everybody, this is going to be our PLC lab preparation. I'm going to walk you through a few things that you need to know before we ever get started with our lab. So let's get started. First thing we're going to look at is a couple different type of processors that we'll be using in our lab. So the RS Logix 500 software is compatible with multiple processors, but the two common processors that we're going to be using is a Micrologix PLC and a SLC 500 PLC. Now in our hazard classes, we're going to be using more of the SLC 500s and fewer Micrologix. In the Jackson classes, we're going to be using more of the Micrologix and fewer SLC 500s. They'll both typically do the same thing. The dressing's just a little bit different, and the way you wire them is just a little bit different. Let's look first at the SLC 500. So a SLC 500 is a system that utilizes a rack, and this rack is multiple slots for cards to slide in and out. So you can pick what kind of input cards and output cards you want and slide them in a specific slot. Starting over here on the far left, the first thing you'll see is a power supply. This is where you're going to connect the power, your L1 and L2, that's going to supply the power for the PLC. So if it's a 120 volt PLC, your incoming voltage, you're going to have your 120 volts and your neutral tied to a terminal strip in the power supply. Now that power supply is going to convert that down to low voltage DC, and that's what's going to power these cards in the back through the back plane. And you'll see that in another video that I've got, but that card will actually go into a terminal strip in the back, which is called the back plane, and that's what powers that card up. Now if you'll look from left to right, these slots are labeled slot 0, 1, 2, 3, 4, 5, 6, so on and so forth, depending upon what PLC you have, depends on how many slots you have. Slot 0 is always designated for the CPU. The CPU is always going to be in slot 0. Now if you'll look real close right here, we've got a run, remote, and program. This is a key switch on that CPU. I suggest everybody always leaves that on remote, because if it's on remote, we can connect to it with a laptop, we can communicate, we can put it in run mode, or we can put it in program mode with the laptop. If it's in program, you can only program. It will not run a program. If it's in run, it will only run a program. You cannot program to it. So if you've got it in remote, you can control the other two with the laptop. This right here is the RS-232 port. This is the Data Highway 485. That's typical on your SLC 500 processors. This is a point-to-point. This is a point-to-point. The Data Highway 485 will look like an Ethernet port, but it's not considered an Ethernet port. And that's what we'll be using in hazard, and when we use the SLC 500s in Jackson, we'll be using that Data Highway 485 port. Now let's look at our second slot here, which is in this situation is an input card. So for this input card, we have 16 inputs, starting with 0 going to 15. We have two commons. If you only use the even inputs, this common right here is all you need to wire up. But typically you would bring a neutral into this common, and then you would jumper that neutral over to this common. That way you can use any of these points on this card. So when we say input, we're talking about a signal from an input device, and an input device is something such as push buttons, photo eyes, proximity switches, or limit switches. give you a little bit of an example here. Let's look at a PLC that we built. The first semester I taught PLCs. We have 3 inputs on this. We have a switch, a normally closed stop push button, and a normally open start push button. These 3 inputs are wired directly to the input terminals on this Micrologix PLC. Now these lights and this little motor are outputs. They are signals or voltage that is sent from the PLC to these lights to turn them on, or to this motor to turn them on. So an output's kind of, what are we going to turn on? Are we going to turn this light on? Are we going to turn this motor on? An input is typically these push buttons or switches or limit switches and so forth. That's the difference between an input and an output. Let's look back at our SLC 500 PLC again. All right, so our input, let's say we're going to use input 0 on this card that's in slot 1. So the way we would address that in the PLC program would be I:1, so I is the type, that's an input. 1 is the slot, so slot 1, bit 0, which is that terminal. If we're going to use that as a switch, that switch that I showed you over there in that picture would wire directly to 0. So when you flip that switch, let's say this is a 120 volt card. When we flip that switch, there's going to be 120 volts on input 0, and you're going to complete that path down to the common. The common has to be there. And that's going to, in the program, you're going to see that input being made. And if we have that program to say if input 0 is on, turn on output 0, then an output 0 is going to be a light. So this, let's look at our output card a little bit closer. This VAC is where you're going to put, we're going to say this is a 120 volt card. You're going to put a 120 volt potential on this VAC terminal. That is going to relay that information to whatever terminal we use, or to whatever output we're using. So if we're using output 0 and we've got 120 volts on this VAC, whenever the conditions are true in the program and the program tells output 0 to come on, it's going to relay this 120 volts to output 0. All right, now let's go over here and look at the Micrologix for a minute. The Micrologix, you'll have an L1 and L2. If this is a 120 volt processor, then we're going to put 120 volts here and a neutral here. We've got inputs. They act just like the inputs on the SLC 500. You'll have to land a common wire or a turn wire somewhere on the input. And the outputs act just like the outputs on the SLC 500 over here. You're going to have a VAC terminal, and that VAC terminal is going to be relayed to specific terminals on the output. We'll learn a little bit more of that when we do our hands-on portion of the lab, but we need a basic understanding of how this works. Now, addressing the Micrologix is going to be similar to the SLC 500, except for where we don't have different cards. You're going to have a typical input : 0/0, output : 0/0. That's how that would address. Now, within the program, we have instructions. The 3 most basic, and the 3 that we're going to look at first, are XIO, examine if open or examine off; XIC, examine if closed or examine on; OTE, output to energize, so let's turn this on. Now this right here looks like a normally closed set of contacts that you would remember from your motor controls, right? Do not think of that as normally closed set of contacts. In the PLC world, as an instruction, This is examine if open or examine off. Otherwise, go look for a 0 in the bit box, and I'll show you a little bit more about the bit box in a minute. This is examine if closed or examine on. Go look for a 1 in the bit box. So that terminal that we've got our push button wired to on the input, if that terminal has 120 volts in it, you're going to have a 1 in the bit box. If it doesn't have 120 volts on it, you're going to have a 0 in the bit box. I know this may be a little confusing to you right now, but it will all make sense, I promise. Output to energize. It kind of looks like, it kind of resembles a coil, right? Like if we saw this in our ladder logic, and we had that, and you know, it might be control relay, right? So that is the same thing. That's what are we going to energize? It may be a coil, it may be a light, there's multiple things. So it looks similar to the ladder logic version of your output device, whatever you're trying to energize. And what this is called is output to energize. So what do we want to turn on? If we're wanting to turn on a light, we may address this instruction as an output and wire that output directly to a light. Now I'm going to show you real quick a little bit about the bit boxes. We're going to open up RS Logix 500, and let's say we've got a Micrologix 1100 Series B. That's typical for what we use in the Micrologix. So if you look at your input tag files, these are the bit boxes like I was talking about a minute ago. So if you energize one of these inputs, that's going to turn to a 1. So all of them right now says 0. I'm not even connected to a PLC, but if I was, and I could trigger that input, I could turn that to a 1. And that 1, when I say go look for a 1, that's what I'm talking about. So same for an output. If the output is on, there'll be a 1 in the bit box. If the output is off, there'll be a 0 in the bit box.